this video we're going to learn the transmission of the nerve impulse, the mechanism how the nerve impulse it gets transmitted from one nerve to another. Even this question can be asked in the examination with the alternate of any of the physiology like alimentary canal or physiology of digestion. In place of that, this question can ask. So first of all, a nerve fiber, it conducts impulses from one neuron to other. Now neuron, it is basically the nerve cell. The impulses are transmitted from one nerve cell to another, and then in this way it gets transmitted from the place of sensation to the brain. So now in this topic, when we are told to write about the transmission of the nerve impulse, the mechanism, we need to write how exactly the sensation, it means that impulse, it gets transmitted from one neuron to another, and what causes it to transmit. So as I said, a message is conducted along a nerve fiber in the form of electrical impulses. But exactly what is an impulse? So if you see, impulse is basically a wave of excitation that travels along a nerve fiber. So if this is the nerve fiber, this is the nerve cell basically. So here is this is just a rough figure. This is the nucleus here. Now these are the dendrites here. This is the cell body, and this is the axon. Okay, so in this topic we're going to talk about non-myelinated type of neurons. Basically neurons are of two types. One is myelinated and one is non-myelinated. In myelinated, you can see the myelin sheaths are present in this way. Okay, but in non-myelinated, these sheaths are not present. It is simply a smooth one. So we are talking about how the nerve impulse gets transmitted in this non-myelinated type of neurons. So basically a message is conducted along this nerve fiber to another nerve fiber which is present here in the form of impulses. But what is basically an impulse? So impulse, it is a wave of excitation which is stimulated either electrically, mechanically, thermally, anyway. Now what happens is that when there is sensation, a wave of excitation occurs here. Wave of excitation occurs, and this wave of excitation, it transmits. It means first this area gets excited, then this area gets excited. In this way all the area goes on excited one by one. It goes on being excited, and this excitation is caused by certain factors. Actually mainly electrically it gets excited. So how exactly this excitation, wave of excitation occurs, that we're gonna read in this. So once again, do not get confused. What happens is that whenever we have a sensation, the message is transmitted from that part of the body to the brain. But actually how it gets transmitted? It gets transmitted in the form of electrical impulses. So basically, what is an impulse? What is an impulse? So impulse, it is the wave of excitation. So this wave of excitation is basically initiated either electrically, thermally, or mechanically. So we'll be reading how this wave of excitation, it is initiated. So like all the other cells, these nerve cells or neurons, they are also present in a fluid environment, and that fluid environment is known as interstitial fluid. And this interstitial fluid, it contains ions like Na plus ions, it has K plus ions, it has Cl minus ions. So in such environment, these nerve cells are present as of the other cells. So now the mechanism of the transmission of nerve impulse, it is, trust me, it's very easy. We can just describe it in 3 to 4 steps. So we have the first step, which is known as the resting potential. Usually it is known as polarization. This is the first step. So what happens is then, now inside we'll talk about this portion. This is the axon of the neuron. So what happens is that inside this axon, if you magnify this is the axon part. Okay, here is the cell body, and here are the two ends containing buttons. So this is the axon, this part. Okay, so what happens is that at first, in the resting potential phase, in the polarization phase, initially it consists of Na plus ions inside this. Now you need to remember this. First of all, there are Na plus ions inside these axons. Okay, Now what happens is, under this resting phase, under this resting condition, these sodium ions, Na plus ions, they are transported from this inside part to the outside part in the interstitial fluid. So in this phase we are seeing that the Na plus ions which are present inside the axon, they are going outside. And this condition, this type of process, it happens through special channels which are known as sodium channels, and the process is known as sodium pump. Sodium channels are such spaces from which these Na plus ions can go outside. So through these sodium channels a sodium pump is created. It means Na plus, it goes to outer side from the inner side. Now due to this it becomes more positive, because Na plus ions are there, so it is an electropositive ion, so it becomes more positive and this part becomes negative, and this case is known as polarization. Okay, this condition is known as polarization. So basically what is the polarization? Polarization is such a phase, or you can call it resting potential. Resting potential or polarization is such a phase in which the Na plus ions, they go from inside to outside, and on the inner side there is development of the negative charge, and on the outer side there is development of the positive charge, and this is all about the resting potential. Then we have the second step, which is known as depolarization. And now depolarization is known as action potential. So by name we are getting the depolarization must be opposite of this polarization, because D is added there. So yeah, it is the opposite. Now what happens is that this sodium ions which went outside, now again they come inside. Yeah, I know this is a bit controversial type, but see, Na plus ions, they went outside, again Na plus ions will come inside. So again positive charge will be developed here and negative charge will be developed outside. Now this type of condition is known as depolarization or action potential. It means such a condition in which there is development of the positive charge on the inner surface and negative charge on the outer surface. Such condition is known as action potential or depolarization. So that's about the resting potential and depolarization. In this way you are seeing that the initial phase is getting restored. But now one thing, remember, see, this depolarization, why it occurs? It occurs basically at the place where there is stimulation. First of all, there was normal phase resting potential where only Na plus ions were outside and there was negative charge on the inner surface. Now what happens is that in depolarization, whenever any type of stimulus is acted upon, it means any type of stimulus, it stimulates this area. On that particular area, what happens is that this Na plus ions, they come inside, they rush inside, it becomes permeable to Na plus ions. So Na plus ions, they rush inside and there is development of the positive charge on the inner surface and negative charge on the outer surface. So there is an increase in the permeability of the membrane wherever the stimulus is acted upon. This is just the opposite of the resting potential, the polarization. It is just the reverse of that. So it is also known as action potential, or you can call it reverse potential. Now we have the last step, which is the repolarization. So by name again it is clear that repolarization must be similar to polarization, because it is the state of achieving the polarization again. So see what happens is that, but this is slight difference. Once again, see, Na plus ions, they went outside, again Na plus ions, they came inside at the place where the stimulus was acted upon. Depolarization. Now in repolarization, what happens is that after all the Na plus ions, they come inside, at the same time, after the Na plus ions, they come inside, at the same time what happens is these sodium gates or sodium channels, they are closed so that no more Na plus ions can come inside, but at the same time potassium gates are open. So sodium gates, they closed, and potassium gates, now these are the K plus ion gates or channels. These gates, they open, and due to this what happens is that K plus ions which are present inside in axons, along with Na plus ions, even K plus ions are there. So these K plus ions, they go outside. Now when the K plus ions, they go outside, again there is development of positive charge on the outer surface, because K plus ions are also electropositive ions, and when they go outside there is development of positive charge, though there are Na plus ions, but K plus ions are more electropositive, so more positive charge is developed outside and negative charge gets developed inside. So again you can see that the positive charge outside, negative charge inside. It is the case of resting potential, positive charge outside, negative charge inside. It means that this process, repolarization, it is just a process of restoring the original condition, which was the polarization. So it is known as repolarization. So once again, if you see from the starting, what happens is that in resting potential, the Na plus ions which are inside, they go outside, and since they go outside, there is negative charge induced on the inner surface and positive charge on the outer surface. And in depolarization, a type of stimulus, it acts on the axon, and at the point where the stimulus it acts, at that point Na plus ions they come inside, and again there is development of positive charge inside, negative charge outside. But in repolarization, what happens, whenever these Na plus ions are coming inside, K plus ions gate also open. As the Na plus ions are coming inside, K plus ion gates also open. So when K plus ion gates open, they go outside, and again the original condition is re-established. Now basically repolarization is the process which is establishing the original condition, restoring the original condition. So but what is the use of all these things? Now all these things, the development of positive negative on outer and inner surface, it is said that according to the theory, it is said that these type of fluctuations in the charge and this type of electric field which is created, it provides the critical threshold for the change for the charge necessary to excite the nerve fiber. Now what I mean to say from that is that these type of the electric field which is created, these type of changes, they help to create the necessary wave of excitation. All these things, they excite the particular part, and that is exactly the wave of excitation. Now this excitation, it goes from one point to the other. In this way the impulse is getting transmitted. So now you got that all these things are happening just so that the wave of excitation can be created. So all these changes, they are exciting the nerve fiber. So now I'll tell you from the starting again, and now you will understand better. So this is all for the wave of excitation. What happens is that Na plus ions, they go outside. I'm just summarizing all the things. Na plus ions, they go outside. When they go outside, negative minus charge is there and plus charge is outside. This is the normal condition, which is the resting potential. Resting phase, it means Na plus ions are outside. But whenever a point is stimulated, now see, impulses are transmitted because a point is stimulated. That impulse need to be transmitted to the brain. Suppose we touch something, and in that sensation it is stimulated. This portion is stimulated, and at that portion, the nerve fiber where it is stimulated, at that portion of the nerve fiber, the Na plus ions, they start coming inside. When they start coming inside, the positive charge is developed here, and minus charges are outside. Now this creates the wave of excitation. It means these changes, they excite the nerve fiber, and then excitation can be carried to other parts, to the brain. So this portion is exciting the nerve fiber, Na plus ions coming inside. But now what is the use of repolarization? Now repolarization, it is basically the phase which is restoring the original condition. Now Na plus ions came inside. Again, the original condition needs to be re-established so that it can be stimulated again, isn't it? The Na plus ions will come inside, only then it will get stimulated. So right now the Na plus ions are inside. So Na plus ions are inside, it means positive charges are inside. For it to get stimulated, then again it's the initial condition should be established. So repolarization, it is basically the process which is establishing the original condition, and till the time original condition is not established, again the nerve fiber, it cannot be stimulated. So this period when the nerve fiber cannot be stimulated and repolarization is taking some time to restore the initial condition, this period is known as refractory period. Okay, so that's all about the nerve impulse transmission in a non-myelinated neuron. So when you write in the examination, that's all you need to write. I know it is a bit short, but that's all you need to write. You just need to write about the resting potential, depolarization and repolarization, and you need to draw some necessary figures. Now the necessary figures you need to draw, basically this is the only figure, but this is just a rough figure. So the fair figure will be somehow like this. You can see I'm just drawing the axon part. The first figure will be of the polarization, in which the Na plus ions which are inside, you can see these Na plus ions will go outside, and the area which in which it is going outside, there will be development of positive charge outside and negative charge inside. This will be the figure of the polarization. Then for depolarization, you can draw that Na plus ions which are outside, it is coming inside, and when it is coming inside, the positive charges are inside and negative charges are outside. Now this excites it, necessary excitation is created here, but now again repolarization should be established. So for repolarization, you can draw that Na plus ions are inside, but K plus ions which are inside, they are going outside. So there is establishment of positive charges and negative charges inside. So in this way, these are the three necessary figures you need to draw in this transmission of nerve impulse. But yeah, this was about the non-myelinated state. Even you can give an extra information at the ending, that's your wish, about the myelinated state, how in myelinated neuron this nerve impulse transmission occurs. So what happens is that in myelinated neuron, you can see in the axon myelin sheath are there. So in this myelin sheath, between these myelin sheath, areas are there. Now these areas between the myelin sheath are known as nodes of Ranvier. So what happens is that in this type of neuron, the wave of excitation is created here. Now this excitation, it jumps here in one node of Ranvier, then in another node of Ranvier. So in this type of neuron, what happens is that the wave of excitation, it jumps from one node of Ranvier to another node of Ranvier. The depolarization, it is jumping. Depolarization, basically the part where the excitation is created. So depolarization jumps from one node of Ranvier to another, and this type of movement or conduction is known as saltatory conduction. Okay, so two words you can remember: a refractory period, the period during which the repolarization takes some time, and at that period the nerve fiber cannot be stimulated again. Saltatory conduction, you can see the wave of excitation or the depolarization, it jumps from one node of Ranvier to another. But now see, this is all about you need to write in examination, but an extra information I want to give you here. If you see that Na plus ions were inside here and Na plus ions are going outside, so basically this is the resting potential. This is a cycle, okay, understand, this is a cycle that Na plus ions were inside, it went outside, Na plus ions outside went inside, and now K plus ions, it goes outside. So again you are seeing that Na plus ions are inside, now K plus ions went outside, but Na plus ions, they are inside. So I said it is a cycle: resting potential, depolarization, repolarization, again polarization, depolarization, repolarization. So Na plus ions are inside, so after this what will happen, these Na plus ions will go outside, and when it will go outside, it will be called as polarization. As I said, Na plus ions are going outside. So basically it is a cycle which is repeating itself. So you can say, if you summarize the cycle, first of all, Na plus ions, it is inside, it goes outside. Now Na plus ions, it is outside, it comes inside, and K plus ions, it goes outside. So again this cycle is repeated, that Na plus ions which are inside, now it goes outside, Na plus ions outside comes inside, K plus ions inside, it goes outside. So basically it is a cycle which is repeating itself, and this cycle which is repeating itself again and again, this provides the necessary charge for exciting the nerve fiber, and then the excitation can be carried out to the brain. And all these things, they come outside and inside from the sodium gates, potassium gates, sodium pump, potassium pump. So that's all about the transmission of the nerve impulse. I hope you got this chapter, and I'll provide you the necessary figure again at the end of this video, which you need to draw in the examination. And the description part is not quite long, it's very short. So that's all for today. Take care, goodbye.